So let me copy this. Extending inodes. You will get, sometimes you get a good fun at work here. So I did ls here, and it has 104,000 files here because the file size could be 0 KB, but it's using the inodes, okay? So for you to be able to extend the inodes, the good rule of thumb is whoever is using that file system, just tell them that it's better they delete some files here. Okay, so I'm gonna just put in a note here to create a massive amount of files. Okay, so just simply run this command. When you run this command will create 110,000 blank files. So it will start with file 1. Okay, the first one, it's actually a loop. So first one will become file 1, the second will file 2, and the last one will be file 110. It will get the last number here, okay? So let's see here. So let me clear this df-h. So we're looking at IBM folder, and it's only 29% full, okay? But if you look at df-i, this command, it's telling you that the disk, there is no more inodes left. df-i is specifically used for checking the inodes. So the thing I'm showing you here is you will run into situation, but you don't really have to extend the inodes, the size of the inodes here. I'm just showing you just so you know when you went through this class, so that you know how to do this. Okay, so let's do this here. So what I'm gonna do is run the command to run the inodes, command to extend inodes. Okay, so you got to be very careful when somebody says you just simply extend the inodes here. Make sure you get in writing and open the change management CR. It's called change request, okay? Once you have that, once you have that, then you could go ahead and extend the inodes, but it will destroy all the data on the disk. Okay, so let me get out of here. Let me clear the screen. So what you want to do is you have to unmount the disk first. Umount /IBM. It's unmounted. Okay, now what you have to do is you just have to run the format command here. So you do mkfs dot. Okay, so you have to find out which file system it is. Okay, so if it's to find out the file system, you type blkid. Okay, and then the one we are dealing with is, which one we are dealing with actually? We are dealing with dev/sdb2. So dev/sdb2 is this here. So it's a XFS file system. So you have to run the XFS file system command. So what is the XFS file system? mkfs dot xfs. Okay, so this is the command. So when we were here, we created the file system. So let's see here, blk mkfs xfs. Okay, so look at the difference between this command and then the one I'm going to show you right now. So here you said like mkfs, okay, and then /dev/sdb2. when you run this command, it will be random, it will be generated randomly. It will give you the random inodes. But if you want to specifically name or assign the number of inodes you have to do, you do -n, and then I'm going to assign 1 million. Okay, I'm assigning 1 million inodes here. That's what it means. And what will happen is any data on the disk will be gone. So make sure you are not doing under stress and you're doing it under the CR, and then check with one of your co-workers before you really do this. Okay, and if you hit enter here, it will say required unless it's giving me mkfs/dev usage mkfs block size is required unless device name. I'm giving the device name. What's the problem here? Okay, maybe it will not take a million inodes here, so let's make it 500,000. Okay, so 500,000 inodes. I'm busy. Get out of here. Close the door. Go. Okay, sorry about that. Okay, let's see what is the error message here. So it says device name is required unless -d name equal is given block size. mkfs.xfs, right? That's the same command. mkfs.xfs -n, capital N, then I'm giving you the number of inodes I need, and so I'm gonna do blkid sdb2 dev sdb2 mkfs.xfs -n 500,000. Okay, and I'm gonna hit enter. It just won't take it. Okay, df-i/dev/sdb2. Give me 1 second here. Mount /IBM df-i. Oh, my bad. It's already using 1 million, right? So so I'm gonna give 2 million now. 2 million. Before that, you have to unmount it. So you mount /IBM. So it's unmounted. And then I'm gonna say mkfs.xfs, and then I'm gonna give that many number of inodes here, but it's not cooperating here. So what you do is you put on Google, increase inodes on XFS file system. So here's the question here. So this is a Red Hat verified question, and you have to log in to see that. So I don't have a login. Space allocated to inodes. Oh, the command is xfs grows. Okay. Use xfs grows command to increase the size of the xfs file system. And an option does not actually extend file system, but just prints. Okay, so let's see here. I don't think it will work though. mkxfs, let's see here, xfs underscores grows hyphen n. No, I know it's not gonna work. So let's see what the problem is. XFS, how to increase the amount of disk inodes in Linux. XFS inodes. Let's see here, which XFS? That's strange. That is strange, right? The XFS file system is installed. The command, hold on, yum install XFS. No package XFS is available. He's showing you the ext4, which we don't need. Red Hat creating and resizing XFS partition. blk mkfs dot xfs. No, it's not doing here, so let me try -d in there. Device name is required unless -d name. Okay, so blk id SDB2, right? Okay, maybe I'll give I instead of N. No. Inode size log label. Give me 1 second here. Let me run part probe here. Part probe df-h. So it's not mounted. I ran the part probe. Now I'm going to run this here. Instead of I, I'm going to say capital N. Still won't do it. No option available. N naming label VQI is for inode size. Still not doing it. That is so strange. Okay, so we'll keep this to the side here. I'll show you how to do it on so this one I'm gonna put it in a red color. So we'll come back to this here. Okay, but if you do df-h and let's look at the one which is this one here. For example, if you need to increase the inode for SDB1, right? So let's see here, df-i dev SDB1. So it has about 500,000 inodes here. Now if you want to increase the inodes for that, you do mkfs dot xfs that ext4. Okay, then hyphen n, and I'm gonna give about 1 million inodes, and then the location, which disk I want SDB1. So what will happen is all the data on SDB1 will be gone. Okay, so I have to unmount it first. I'll run the command here. Done. So what happened now is if you do df-i and then the information here, so it gave you, it won't know unless you mount it. Okay, mount, and then it was mounted to data folder, right? df-i. Now remember earlier this number was 500,000 and change. Now we change it to 1 million, but the data is gone. So the use case for this would be that application may be written using this location here. Okay, they may not want to mess around with the code Instead of that, they might ask you to increase the inodes here so that they continue using the same location. Okay, so I'll find out about MKFS here, but so far we were able to just increase the inodes fine for this data disk SDB1.
I have a question.
Yeah, sure.
You think that was on SDB1 before you mounted it again and changed the inodes? When you did that, when you remounted it and changed the inodes, it deleted everything that was on there from before, right?
It deleted when you ran this command.
Yeah. So if you said, well, if the developers will ever have anything written on there and they want you to increase the inodes, if you increase the inodes, wouldn't that delete everything they broke?
It will delete. It will delete. See, here's the thing. The real world scenario, it's complex, and what they wanted is that they might want to capture like every activity going on, every activity or the logs of the application, who's logging in and all that from the internet. That will be generating the 1 kilobyte of file. The file size will be 1 KB or 0 KB or 2 KB. What will happen is they will suck up the amount of inodes you have. So it is a good idea that when you are actually building the system for application team, you sit down and ask them how many inodes they need. And these are the valid questions here, and the application team should have some Linux background, or else they won't be able to function properly in their environment. So check with them how many inodes they need. They'll tell you like, I need a 5 million or 10 million or whatever. Based on that, you do this. But then again, they are, the disk space in the corporate environment is unlimited. You could keep adding the disk. But here in this scenario, even if you increase the size of the disk, it won't help because the inodes are only static. So you have to increase the size of the inode. So this is a very dangerous command here. All data will be deleted. Okay, so it runs through that, and once you mount it, you could see the inodes have been increased here. So this is the inode information before you ran the command. Now after you ran the command, these are the inodes here. Even though you said 1 million, but it's not. In computer world, you have to understand some of the things on the computer itself is a metadata that computer writes itself. So even though you say million, it's gonna give itself this number here. Okay. This number may not be available for you. Just like I explained about if you go buy a cell phone for 64 GB, you wouldn't exactly have 64 GB of space on the cell phone. You would have much less. If you get 50 GB, that would be really nice because the size of the operating system is getting bigger and bigger. Okay, so those are the things you have to keep in mind here. You will rarely get this request, but I've seen one time. But the very good thing you should do is you should tell them to like go into the folder here, right? Okay, which folder is it? Data. And you do ls-l. And here, when we go into administration, you would know. Here you see this file is created by root here, right? But what you could do is in real world scenario, the files, if I'm logged in as Zafar, will know who created the file here. So if the application team, if the file is generated by an application, like for example Oracle database, it will have the it will have name here, the user ID, the application user ID will be here. So most of the time what I do is I do the output and send them the output and tell them that this user ID is sucking up all the inodes here. If possible, delete the old files so that you will have some inodes left. If not, if they say like, no, we want to keep everything, and if you want to increase the data, then they are the one who have to initiate the backup, and that's their responsibility. And once that is done, then you do it. So this is where the change management comes in. Okay, I mentioned here, where did I? So here, make sure you're working under CR. Okay, so I mean, when you go into a job and you don't have to know everything, I mean, nobody is expecting. Even the similar job, you go somewhere else. If you're doing the same exact job for 10 years and you go somewhere else, so the environment will be hugely different here, how things are done. When I was working for Apple, they barely had anything on VMware. They had a lot of stuff on physical hardware. So other than that, every other corporation you go, they're using VMware, AWS and all that. So it just depends how the environment is set up. So you'll get some training there. So I'm going to say ext4 file system. Okay, so that's about it when it comes to inodes here. So now on the same hard drive, same disk, we already have two file system here, right? One is a ext4 file system and other one is a XFS file system. It's a huge difference. Okay, so now what we could do is we could continue on adding using some more disk space here. So we used 8 plus 2, so we have 6 more gigabytes of disk space left. Okay, so now is the time to talk about let's see, how do we okay, so let's increase the size of the XFS file system here. Okay, at least let's do that. So I'm gonna put a row in here. Okay, so I'm gonna tap, and what I'm gonna do is increase the partition. Increase the size of the partition is a safe bet. So I'm gonna clear. I'm gonna say mount hyphen. If I do df hyphen h, see the IBM data folder is not there, right? So if I do mount hyphen a, what does mount hyphen a does? It will mount the file system reading the FS tab. And this is it. The moment ago IBM was not mounted, now it is mounted. Okay, so the size of IBM is 2 GB. Let's go ahead and increase it to another 2 GB, okay? So let's make it 4 GB. Okay, so what you have to do is you have to see what is the size of the disk. Okay, so first you have to find out the size of the disk here. So what are you going to do is you do fdisk slash. Now before that you have to unmount it. umount slash IBM df-h. So IBM is not there. Now what I'm gonna do is I'm gonna do fdisk, but if you do lsblk or do blk, lsblk actually, yeah, this is a good one. When you type lsblk, you will know that you want to increase this size here, but this is a partition on SDB. So what you have to do is you have to do fdisk slash dev slash SDB and hit enter. And you do P and hit enter partition. So you have to look in here and see the disk size is 17 GB. Okay, and I thought we have 16, right? Okay, so there is a new technology called gigabyte. I'll go over that in a minute here, but let's look at it here. So the size, total size is this many bytes. Okay, so it started, the first partition started here and it ended here. The second partition, wherever the first partition stopped, the second partition started there and ended here. Okay, now from here all the way to so we have from here to here we have you have to do some math here to find out how many blocks, how many bytes is still available. So I'm not worried about that, but if you do like BLK ID and all that, you should be able to figure that out. Looking at here, it says SDB1 is 16 GB byte. Out of that 8 GB byte is used and 2 GB byte is there. So you do the math here, 10 GB byte is used up, and so we have 6 GB byte. So here what I'm going to do is I'm going to actually delete the partition here. When I delete the partition, the data is not going to be deleted. The data will still be there. In fact, let's go back. I'm going to quit here and I'm going to go to, I'm going to do df-h. I'm going to do mount-a. So IBM should be there, right? So let me go into /IBM. Oh God, okay. All right, we have millions of files in there, so I thought we didn't have any. So I'm going to clear this. I'm going to do fdisk /dev /SDB and hit enter. Okay, and I'm going to do P and hit enter to see there is a primary partition in there. So let me get the menu here, M. So I'm going to delete the partition here. So I'm going to push D and hit enter. Okay, so let me start copying this. Okay, so I did that, M and hit enter for the menu. Okay, now the second command I need is D and hit enter. So I'm going to delete the partition. Okay, now it's telling which partition you want to delete. 1, 2. The default is 2 because it knows that you cannot. You could delete this, but generally speaking, you delete the last partition before you delete the first partition. Okay. So here partition number 2 is SDB2. So it's telling you default is 2. So select 2 and hit enter, and it will give you partition 2 is deleted.
Question for you right quick. If you like mistakenly delete a wrong partition, is there a way to undo or no?
Unless you write it here. If you do W and hit enter, then the partition is deleted. But data is not deleted. Okay, so you could recreate the partition, but the data will still be there. Okay, the thing that will destroy the data is running that mkfs or mkxfs file. When you create the file system, the data will be deleted actually. Okay, so I'm going to write and enter. Okay, so what happened here is rereading the partition table failed with error. Device resource busy. The kernel still uses the old. Okay, so the disk next reboot or after you run part probe. Okay, so let's run part probe here. It's giving us an error here. Why is it's giving us a df-h? Oh, you have to unmount it. You mount IBM. Okay, now let's do, so I have to put a note here. Okay, now I'm going to run the same thing again. So clear fdisk p. The partition is, oh, the partition is gone. So it did went through that. Okay, so I'm going to quit. I'm going to clear this. Obviously this is not how you do it, so this is an inefficient way to do it. Okay, next big topic is LVM, logical volume manager. That is the one that we are using all the time, not the fdisk. Okay, so let's see here, what do I have now? What I need to do is I need to create the partition. So I'll do this here, dev sdb1, and then I'm going to say p print partition. There is nothing to show. I mean, what is showing here is the existing partition, partition 1. Now what I'm going to do is I'm going to check the menu, and according to the menu, if I push N, it will add a new partition, N, and hit enter. Okay, so it's gonna give me N as an option here. Now I have P for primary partition and E for extended. So most of the time you have to use primary, and it says 3 are free. Why 3 are free? The most you could have is 4 primary partitions. Once you have 4 primary partitions, you cannot have any more partitions on the hard disk. But what you could do is you could create extended one primary partition. Within that partition, you could have multiple extended partition here. Okay, I'll find the picture here later on. Okay, give me a minute. So P is default, so I'm gonna push P and hit enter. Okay, then again now the partition number is again easy 2 to 4. So the default is 2 here because 1 is already being used. So I'm gonna say 2 and hit enter. And then over here, so this is the starting sector here. So if you go up here, the end block for the primary partition is this number here. Okay, and then if you look at the one it's giving an option is it's 64. See, it's starting from 64. Wherever the first partition ended, right from there the second partition is starting. Okay, so you hit enter. Okay, so the default okay, so you hit enter here. Now you have to give the size here, what size you want to give here. So what you have to do is we decided on extending 2 more, so total of 4. So you type 4G, 4 and uppercase G. Okay, and you hit enter.
You have to do plus 4G, right?
Yeah, thank you. Plus 4G. Okay, so let me capture this part here. Okay, you could do P and hit enter. So now what is you doing is giving you, you could look at this number here. It starts with 8, so probably 8 gigabyte. 4 is 4 gigabyte. Okay. So you have 2 partitions here. Okay, and then now what we have to do is write and exit. Okay, so the partition has been created. I'm gonna get rid of this much information here. And
Are you okay?
okay, and when you hit W and enter, that means write and exit. Okay, so the partition is now written here. So this is an optional part probe. The partition will be recognized by kernel sooner or later, but if you do part probe, you're actually forcing it on it to recognize the partition here. Okay, so if I do V, okay, now if you do LSBLK, okay, so now you should see the size is 4 GB. Before it used to be 2 GB. Okay, so now I'm going to say mount -A. Okay, it mounted here, and let me do dff-h. Okay, so you think the size has increased, right? The size actually didn't increase here, so you have to actually run one more command.
I have a question for you, sir.
Yeah.
So after when I put the mount -A, it's telling me wrong FS type bad option bad super block on dev SDA1.
Which drive you were doing fdisk on? SDB1 or SDB2?
I think I'm on SDB1.
Okay, good. So you have to remember, if you're using SDB1, I think we use SDB1 as a ext4 file system, not a XFS. Do lsblk and tell me what is under SDB1. When you look under SDB, right there, this part,
Uh-huh.
what do you see? What is SDB1? How much is the size?
SDB1 1 gig.
SDB2?
SDB2 is 15 gig. Oh, I'm sorry. SDB1 is 8 gig and SDB2 is 4 gig.
Okay, so you're with me. You're with me. But now that we mounted, but the size is not registered here. So there's a special command you have to type, xfs underscore grows, GROOWFS, xfs grow, xfs grow file system. Okay, and then you have to type /dev/sdb2. Okay, looks like it went through. If you do dff-h now you see it's 4 GB.
Okay, so I'm still like when I put that command xfs underscore grow fs space /dev/sdb2 and it returned is okay. It's a xfx blah blah blah. It's now a mount xfs system file.
So mount it first. Mount space -A.
Yeah, that's what I did. It's telling me wrong FS type, bad option. When I
Okay, so
put
it's
mount,
not into FS tab. So mount it manually. Mount, then space /dev/sdb2, and then you have a IBM folder. So mount it to IBM folder.
/IBM. Okay, now it's telling me it's write protected mounting is read only unknown file system. No.
All right, give me your team viewer.
It's 469-209-539.
Okay, password.
EH2
Okay.
V39.
Okay, so let's do BLKID. So I'm looking at SDB1. You don't have SDB2. Where is SDB2? LSBLK. Okay, so you see SDB2 there, right?
Yes, sir.
So now what you have to do is cat etc fs tab. So you have SDB1. See SDB2 you don't have it in here, so mount it manually. Mount, type it in mount, then space / dev SDB2 space / is it IBM? No, is it capital? Yeah, there you go. Hit enter. Write protected unknown file system type. Okay, so now let's go ahead and do I think you didn't create the file system there here, so give me 1 second here. fdisk /dev /sdb2 sdb, and let me look at the partitions here. So you have yeah, this looks good here. ID is 83. You do W and hit enter, and then do part probe. PARTPROBE. What it's going to do is it's going to send the probe, and then it will register it with the kernel, the operating system. Why are you using? Why are you not using PuTTY, buddy?
I was gonna log in. I was having a connection failure, so I just decided I'm just gonna run it directly on practice.
Okay, fine. As long as you have good understanding what is going on, I'm not worried about it. Dev SDB2 is still not registering. So actually the file system, I think you took out the file system. So what you have to do is mkfs dot xfs. Let me run the xfs grows command here. You already ran the xfs grows command, right?
Yes, sir.
525 xfs underscore grows fs, not s, grow fs. It's moving fast. Dev /sdb2.
Yeah.
Okay, so now actually you have to do the first command, mkfs.xfs dev sdb2. Okay, now do lsblk. Okay, now do blkid. Now you see SDB2 is being registered here, okay?
So do you not do the part probe on it, or?
Do not do what?
So now I guess now we're mounting.
Yeah, mount dev SDB2
Two.
to IBM, right?
Okay. Okay, now it's there.
Yeah, but the data is not there because you didn't. You may not have followed the way. Okay, but anyway, you got the idea here. You could delete it and extend it to another 2 GB and then make it 6 GB, and then you could do it offline. Okay.
Okay, sir.
So now look at this here. The IBM. If I go into IBM, If I go into IBM, the files should be in there. Okay, looking in here, it's 15% is being used. So if I do ls-l file 1, it comes up, the file 1 is there. Okay, if I do it's going to run through all the million files in the 500,000 files or whatever.
That's right.
Well, you know the data is there because it's there. So what you do is I'm going to cancel it here. So you see the data is there, okay? There is no way data is not there. Data is there actually. So what I'm going to do is all this is good. This is good. I need to so I need to show this here that it's there, but you have to run okay, so I'm going to highlight this here. So once you run xfs grows, and if you do dff-h now, then now you could see the size has been grown to 4 GB.
So would you mind writing that touch file command in the chat, please?
Okay. This one?
Yes, sir.
Okay, so let me put it in chat. Let me send it to everybody. Okay, you got it. Okay, that's about it here. So I'm gonna put in some partition information. Then we're gonna start the swap file. Okay, so normally you have you can have maximum of 4 primary partitions. On single disk. Okay, if you want to create more than 4 partitions, then you need to create extended partition. Then what happens is, then you can nest then you can nest multiple partitions inside extended partition. Okay, so here's the key: nest. Nesting is like a partition inside a partition. So let's go out to the internet and get the picture. So I'm gonna put in here primary partition. I don't like that. Let me see if I have it on my previous class. So we have so you could have a maximum of 4 primary partitions, right? So the thing is, once you hit 4 primary partitions, that's it. You cannot have more than maximum Okay, so you have maximum 4 partitions here, and so if you want more than 4, create a extended partition. Create extended partition. In that, then you could have like a lot more partitions. I don't know how many more, but you could have a bunch of partitions here. Let's see here. I'm not worried about it. I mean, don't worry about it too much. So all you have to do is create an extended partition, and within that you create a multiple logical partitions. Okay, let's take a good 10-minute break, and then we'll come back here. I'm gonna stop the recording. Okay, so the break starts now. Okay, I'm back. So I hope this picture gives you an idea what is going on here, okay? So now the next concept we'll work on it is swap partition. So get out of here, clear the screen. You do free or you do LSBLK, right? When you see in here, it says swap. So let's concentrate on what learning about swap. Okay, so swap partition. So it says what is a swap partition. how do I, what is the difference between swap file and swap partition? I'm not worried about that. Swap Linux. So swap is, all right, so let me just define it here. So swap is a space on a disk that is used when the amount of physical RAM, physical memory, I should say, physical RAM is full. So let's take a look here. To check the RAM, how much RAM you have to type free -h. So it's telling you that it's 1 gigabyte. It's not telling you in exact gigabyte, it's telling you 900 megabytes. So 1 gigabyte is used. Out of that, this much is used, this much is free. And don't worry about this, we'll come back to that when we're doing troubleshooting. And the swap space is 1.6 gigabytes. And 1.3 is used here. So if you look here, swap, it's a logical partition here. And the swap space is 6 gigabytes, so it's matching here. So the memory, when it gets full, you use the disk space as a RAM. Okay, it's cut out of the RAM here. So if you have a lot of processes running, it will exactly swap partition actually exactly works as RAM. If you have something running there, and if you don't have if the power goes off, everything in the swap will be gone too. Okay, since it's the idea, the reason I'm saying this is it's a part of a hard disk, right? Hard disk could save the data, but here, once you make it a swap partition, it's a volatile. The moment you lose the power, it's gone. Okay. So you compare this with Windows environment. It's called virtual memory, I think, in Windows. Yeah, you come in here. I'm not worried about it. I don't know where it's in Windows is at. Okay, now, so looking at here, so let's continue defining. When Linux system runs out of RAM, random access memory, right? Everybody knows that. Inactive pages are moved from RAM to swap partition. Okay? Swap space can take the form of either a dedicated swap partition or file. Or a swap file. So let me make it bold here. So that still doesn't tell you what is it. So what I'm going to say is what is swap. Okay, so it is a swap is a standby RAM. It's on a standby memory. So when it's needed, then it will be used by the system here. So it's a virtual memory used from hard drive. Okay, so in this case real memory is in our scenario here, the real memory is 1 gig and the swap is 1.6. Okay, so now the total usable size for operating system is 2.6 GB. So if the real memory is full, the swap is utilized. Okay, OS operating system will move inactive processes to the swap memory. Okay, this is like a safety bubble. Safety net for physical memory. Okay, so let's take a look here. Before that, so this is 2 GB also. /devsdb2 and it's XFS. Okay, so 8 plus 4, how much is used up? 12 is used up, so how much we have is 16 gigabytes we have left. Okay, so I'm going to save this here. So you do lsblk So out of 16, 4 is left, right? So now what I'm going to do is 2 GB /dev/sdb. What will be the third partition? SDB what? So it will be SDB3. Okay, so okay. It will be SDB3 swap. I don't like that. I don't like that either. Okay, good. So we have a 16 GB hard drive, physical hard drive. We have a ext4 partition, we have XFS partition, and then now we have a swap partition here, okay? Okay, so let's take a look here. So what we're gonna do is I'm gonna use this. Okay, so our hard drive
Where?
is can you go on mute, please? Okay, so we have this here in there, so let's do this here. Okay, so this is our hard drive. All right, so let me get rid of this. And all right, so this is our RAM, and in there, let's see here. If I have, so this much is this is SDB1. This is SDB2. Okay, so we have here is let me just change the colors here. Okay, so I don't know why it's okay, so I'm not worried about that. So let's do this. So this is 8 GB, 8 GB, and it's /dev/sdb1 and ext4 partition, ext4. Okay, now the next one is this is 4 GB dev/sdb2, and this is xfs partition. And now we have 2 GB left. What I'm gonna do is it will be dev/sdb3 sdb3. Okay, and this will be swap. The partition file system will be swap actually. And then this is the system RAM here, 1 GB. 1 GB, it looks too big visually for 1 GB, right? Let me trim it down. So this one is physical RAM, and this is 1 GB. So what we're gonna do is um, and then another 1.6 GBs from another drive. Okay, so let's do this here. Before that, okay, I'll leave this here for now. Okay, so I'm gonna clear this. So what I'm gonna do is, let's do fdisk again. Fdisk /dev/sdb and hit enter. And you do P and hit enter, partitions, right? Okay, so now what I'm gonna do is I'm gonna go M and hit enter. What do I need? M, just the menu here. So I'm adding a new partition, N. Okay.
I'm sorry, can I interrupt for a minute?
Yeah.
Sorry about that. I just joined and I'm having issues logging into the VirtualBox.
What is the IP there? Are you just can't go into the VirtualBox at all? Check if the IP has changed. Are you there?
Sorry, I muted myself. I think I can't even do that. It wouldn't let me type anything. Would you need my team viewer?
Yeah.
It's the last three are 188.
Okay.
And then J as in Jerry, 8, I as in India, another number 8, I as in India, and number 7.
Uh-oh. You went into emergency mode. So it's telling you to type in the password. So go ahead and give the root password. Okay, do who-r.
Who, WHO?
Yeah. Space -r. Okay. So you're in the emergency mode here. So okay, so let's do DFF and H. So what happened here is one of your disk is gone, I think. System after logging into journal CTL. Dev mapper CentOS is there. Boot partition is there. CTL. So what you did is SD dev slash SDB A1. That doesn't look good to me. So you do cat etcfs tab. So you have dev slash SDB A1. So what you might have to do is VI N okay.
Oh, I think I remember doing that.
So you do save and exit. Let's see if it's gonna save. It did. Now let's do init 6. Okay, so you're in regular mode now.
Okay.
So go ahead and log in and then check the IP. If it's the same IP, then you could connect. Yeah, it looks like it's the same IP.
Probably not.
Let's do this here. Go into bound 0 and make it DHCP. So
Oops. Sorry,
yeah, go there. Go to CD etc slash etc. No, CD then space then yeah, get that. Now remove that space out of there. Now hold on, let me type CD slash etc then sysconfig
Enter.
no, then go into / network hyphen scripts. Yeah.
Are there any spaces anywhere? No.
The good way to know if you have typed correctly is push a tab key, and if you get a space there, then it worked. There you go. Hit enter now. And now do ls. So go into bound 0. VI IFCFG bound 0.
I'm sorry, what? VI and then what?
IF, the very first one you see on the ls when you did IFCFG. Hyphen bound 0. Enter. So make that static, delete static and make it a DHCP. Line 4.
And make it what?
DHCP. Go into insert mode. Yeah.
Or DCP?
No. Do U. Push U on the keyboard to undo it. There you go. Then go into insert mode. Push I on the keyboard. There you go. Go towards the end. All the way end. Now type DHCP. Okay, good. Go down to the second last line, and then go put a pound sign all the way in front of IP towards the left. Yeah, put a pound sign there. And do the same thing in the last line. Well, I'll explain you what the pound sign means when we're gonna do scripting, okay? Literally, it's gonna,
Right.
you commenting it out, that means the system won't read it. Okay, save and exit.
Okay.
Just reboot the system in its 6.
So we're good now?
See if you get IP. It might change. Yeah, it's a random IP, so use this IP 10.0.2.6. It might not work, I think, but try it.
Ten dot 0.2.6.
Yeah. Now take everything out. Start fresh. Yeah, delete all that. Two dot six. Yeah. Save and connect and see what happens. Yeah, I suspect it might not work. The reason it might not work is you may not have one 192.56.0.1. This looks good to me. Okay, so this might work here. Where is the party at? So the new IP is 192.168.56.103. There you go.
Yeah, okay.
Okay, I'm gonna disconnect now.
Thank you.
Sure. So where were we? So now it says what do you want to select? So the default is primary. So we could still use primary here. Okay. So I'm gonna push P and hit enter. And then the partition number by default is gonna take 3. Push 3 and hit enter. And we're gonna use the entire default. And then the sectors, it says 2. We're gonna do +2 GB, capital G, and hit enter. And it says the primary partition is set. Okay, so okay, so the primary partition is done, but we're not done yet. Okay, let's do P and hit enter. It's giving you the swap partition automatically. It's taking automatically. The partition ID is taking 83 here. We don't need 83. What we need is 82. So let's go into menu, and then let's go into list known partition types. So let me copy this here. And I'm going to push L as in Larry and hit enter. So these are all the partition system that Linux is supporting, okay? AIX, FAT12, FAT16, Windows. So now the one we are interested is in number 82. Remember earlier, by default it took 83. We're going to have to change it to 82. Or else the system will not be used as, the partition will not be used as the default, we are creating this partition for swap. So we have to set it as a Linux swap number 82. Okay, so let's go in. And how do we change the partition here? So you have to push letter T as in Tango. It says change partition system ID. I push T and hit enter. Okay, and which partition you want to do it? We want to do it to 3. I'm going to say 3 and hit enter. And then what is the hex code? Okay, the hex code is 82. Okay, now I'm going to do P and hit enter. So now the hex code has changed from 83 to 82. And it's saying it's a Linux swap partition, probably developed by Solaris, Sun Solaris. So I'm going to copy this information here. And then I want to highlight 82 because we changed it to, and let me highlight this entire area here. So this is the one that makes it actually a swap partition here. Okay, and now what you have to do is you have to write and exit. W and hit enter, what happens? It will save it to the operating system. Okay, now I'm going to run part probe. Okay, so part probe is not necessary, but it's recommended because it will forcefully register it to the operating system here. Okay. Now, if you do lsblk, so the partition is there, right? And if you do blkid, so the blkid is not registered here. Why? Because you have to format it. So how are you going to format it? This is how you format it. Is mk swap. Remember we used mkfs and all that. Now we're using mk swap is the command dev/sdb3 and hit enter. So if you do blkid, now you see on the bottom here that when you run this command, is actually doing a bunch of things. It's creating the UUID and it's registering what type it is. Okay. Now, if you do free-h, the swap is still the same. It didn't change. Okay, so what I need to do is I need to make it available. Okay, so how do I make it available? Swap on /dev/sdb3 and hit enter. Now if I do free-h, there you go. The swap is now from 1.6 gigabyte to 3.6. It has increased in size to 2.2 gigabytes has been increased. Why? Because we said so. Okay, so mkfs swap. Okay. Makes the swap usable. Okay, now what you have to do is you have to make an entry in the etcfs tab. So you go to vi, you could do cat etcfs tab, right? Why are we making it? We are making it persistent with the reboot. So I'm going to go vi/etc/fs tab. And I told you to copy the existing line, right? So look at the existing line for the swap is this one here. I'm going to copy this line. Y makes it copy. I'm going to go down here. Go to the new line and then I'm going to do P. It pastes itself. Now I'm going to edit it. dev/sdb3 and everything else remain the same. Okay, this is the beauty of copying the existing line and saving in an exit. Okay, so now I'm gonna clear this. So if I do a free -h, to remove the existing swap, what you have to do is swap off. You have to do swap off. Swap off, and which swap you want to do? dev/sdb3. And if you do free -h, actually play around with this, turning a swap on and off. It will do it. Now let's turn it on and off from the FS tab. Mount -a. I'm going to hit enter. So if you do a free -h now, it should automatically. It says can't find the label ZMPT1. I'm not worried about that. Let's go into VIETC FS tab. SDB3 swap and dev/sdb3 swap, right? This looks good to me. No, actually I ran the wrong command here. So to turn the swap on from the FS tab, you have to type swap on -a. Now do free -h. There you go. And you do swap on swap off -a. Actually it will remove it will remove the original swap also, but I don't want to do that. So we did free -h is
Could you explain again what is the free -h do?
free -h.
Yes.
Yeah, if you type free without h, it will give you the memory information. Free is the command you use to get the memory information. And so this is in bytes. So -h is human readable. So it gives you something which is we could read it and understand. See, look at this. It's just throwing out this number here. This number is equal to 3.6 GB bytes.
Okay, thank you.
Okay, so now what we're gonna do is okay. So let's see. We have good 20 minutes, so we could start LVM. So All right, so this is extra credit here. Over here, we already have the swap on. Okay, so I'm done with this thing here. So here, let's go ahead and start logical volume. LVM, short for logical. This is a big topic, guys. Nobody would ever get a Linux job without knowing this. So it's very, very important. And I'm going to show you everything inside out and practice it as much as you can. Okay, so let's talk about the logical volume. So if you look at your hard drives here, we should have 3 extra hard drives here, right? Go into settings, storage. So you have one more extra hard drive. Is that what we started off with? Only 2 extra hard drives? Disk 1, disk 2. Let's look at the original one here. Everybody check your hard drives there. How many hard drives you have other than the operating system drive? I thought I set it to have 4 or 5. Yeah. So let's spend some time here. So go ahead and shut down the system. We're gonna add some extra hard drives in here, okay? So INIT0. So go back to your practice and go into settings, go into storage, select the SATA controller. So this 2 is 8, right? This one is 16. Put a plus sign next to it and it says create a new disk. And give it a number disk 3, disk 1, disk 2, disk 3. Disk 3 and give it 16 GB.
I'm sorry, I think you went a little bit too fast. I didn't follow it.
Yeah, select. Did you shut the system down?
Oh, yes, I did.
Okay, go into bring up VirtualBox Manager.
Yeah.
And then select practice, go into settings, and then go into storage. On the controller,
Going to setting. Going to setting and then controller.
yeah, I'm sorry, settings, then storage.
Okay. Okay.
And here, look at not the first one, the second one. Click a plus on it, the drive.
Okay.
Okay, so actually I gave it a wrong name. So, and then create new disk and give it a name similar to your practice. PRACTICE hyphen. Now give it disk 3, disk 3, DISK 3. Okay, and then the size here is supposed to be 16. Okay, make sure don't use this to make it up and down, just type it in the 16.00 GB and then click create. So you should see a practice disk 3 in here, and then go in there and add one more, create new disk, and this time around give 24, okay, 24 GB, and make sure you're giving it a right name. Practice hyphen disk 4, okay, and then click create. So you should create a 24 GB disk. So you should have a good 5 disks sitting there and getting wasted.
For some reason, I just did the same thing, but it's not showing under my storage, the one that I just created.
All right, give me your team viewer.
Let me 469209539.
Okay, password.
EH2V39.
Okay, this looks. Cancel this. Okay, so you have practiced this one, this two. Let's go to this three. So add there, plus, and on the top click add.
Oh, I guess I have to add it to it, right?
Yeah,
when I-
your interface is a little different. There you go, practice disk 3. That's where it's sitting. Select that. Yeah, click open. And then choose. Click on it. Click on practice disk 3. What you do there, 1.6 terabyte, delete it. Down on the bottom, delete it. X. Here, I'll do it. Okay, you did it. Yeah, go ahead and select now. No. You have to be selecting the correct thing. Cancel this. Select the controller SATA. Go down. That one. Now do the plus sign there. And click create.
Create, okay.
Now here type practice. Delete all this. Okay, also, yeah, delete all that and give a name practice. The disk 3. And then click create. Okay, now select add. Yeah, the open. Choose. Okay, click on practice disk 3. What? Virtual size. Okay, maybe it's hold on. Let me do it. So you have this one here. Actually, you have too many in there. You already have disk 3 and disk 4 too. You're doing it good here. Disk 4.
Oh, can I delete the one that's 1.56 terabyte?
Yeah,
That one, I think that right there.
it's not giving the option to delete it. What is this here? So if you want to delete it, you have to go to this location here, right? Let's try to go add or create. Let's go in this place, okay? And you have disk 4, disk 3, disk 2. And this one is, let's see the size here. It's not telling me what the size is.
The size is saying 2 megabyte over there.
Yeah, no, I mean, the 2 megabytes is the reason.
The one he needs to delete is the one on top, right under logs.
This
The one
one.
that was 50. Yeah.
Yeah, let's go ahead and delete it. Okay. So if you try to go in there, refresh. Yeah, it's gone. It will
Okay.
go away later on. Okay, good. So you have this 8 GB, 16 GB, 24 GB. So you're good. Okay, everybody else are caught up?
Can you look into mine? I don't know if I did it right or not.
Okay. Yours is 188, right? So
188.
is Adil, right?
Right.
Yeah, give me your password.
It's M41, F as in Frank, N as in Nancy, number 1.
Okay, so you do this too. No, you did it in wrong place here. So okay, let's get rid of it. Remove. So you have to do it in here and then do it plus, and choose the existing maybe. Yeah, let's create a new one here. So plus, create a new disk and do practice hyphen disk 3. Here I'm going to make it 16 GB. Okay, and I'm going to click create. Okay, and choose. I'm going to paste it here, make it 4, and I'm going to make it 24 GB. All right, great. So you're good. This 4 video already exists. So typically, I don't like where is it at? This one here, right? So let's go delete that. So let's create it. No, don't worry about it. I'm gonna give it something like this for hard disk storage already exists. Oh, this would be, no worries, just give it disk 5. You just have to remember it's just name wrong. Okay, so we're gonna work with the disk 2, disk 3, and disk 4. For you it's disk 5. But okay. 24, 16, and 8 GB, okay? So you're good.
Alright.
Alright, so I think we ran out of time. Anybody else have issue? Okay, no issue means, let's circle back tomorrow and then we'll continue from there, okay? So I'm gonna...
Tomorrow,
Thank you, sir.
Cover how to increase the inodes for an XFS file system, because we weren't able to do that today.
Yeah.
Right.
We'll wait for next class here. I will check with my buddies at work and see what exactly they're using. Maybe because the Red Hat, you have to have sometimes a Red Hat subscription to get some answers. We'll see here. So we're gonna work with this, and this tomorrow. So I'm gonna copy and then paste it in here, okay? Okay, so I'm gonna end here. We'll catch up tomorrow, and we'll keep the same time for tomorrow, okay? And then I'll put in a vote to people to vote for next week. Okay, so Adil, I was asking people if they could start 2 hours early, 12 p.m. to 3 p.m. You cannot move, right?
I'm sorry, what time to what time?
Saturday, Sunday, 12 p.m. to 3 p.m.
I think that's fine.
Yeah, tomorrow everything is going to be same. We'll start from next week, okay?
Sounds good.
Actually, I will do a vote throughout the week, and then if everybody agrees, then we will move. If not, then we cannot move.
Okay.
Okay, all right, guys. LVM is very, very important. You will never get a job in Linux if you don't know LVM. So I'm gonna give you everything inside out. All you have to do is practice, practice, practice. I would say practice as much as you can. Destroy the system as many times as you want. That's how you're gonna learn. Because this is the same exact